Okay, let's go. So guys, today is the continuation of our previous lecture called Image and Video Analytics. But today it will be more practical than the theoretical. Today we're gonna try to copy paste the code and train one of the most widely used instant segmentation algorithms called algorithms and models called mask RCNN. And after training and testing this model, there will be some kind of a theoretical part in which I am gonna explain what is mask RCNN, where did it come from, and etc. Any other information. So let's start by some kind of case study on the instant segmentation. Like we said in our previous lecture, our case study will be based on touch vision object detection fine-tuning tutorial, which is located on the official PyTouch website. So in my case, I'm gonna use the Jupyter notebook, but you can use their suggested collab version, but I mostly run everything on my laptop or on my computer. That's why I don't want to run the collab version. So for this tutorial we will be fine-tuning a pre-trained mask RCNN model using Penfield dataset for pedestrian detection and segmentation, which contains 170 images with 345 instances of pedestrians. What does it mean? It means it contains 170 images in which there exists 345 pedestrians which are masked. Their masks were drawn on the dataset. So then in previous lecture I described what is fine-tuning. We take an existing model, trained model, that was trained on some bigger dataset, and we have our own small dataset, and we want the bigger model to understand what is in our small dataset. Why do we do that? I explained on a previous lecture, because the bigger model was trained on a bigger dataset with millions of examples, and it learned many useful features. It can detect useful features, and you have only a small dataset. And if you do not have big dataset, big amount of data, that's the best use case, because you're gonna retrain a lot of features that were trained on a bigger dataset to be able to recognize what is drawn on your dataset, what is located on your dataset. So we're just it's some kind of transfer learning when we transfer the knowledge from a bigger dataset, bigger model, understanding of a bigger dataset to understand our small dataset. So it will show more accuracy than if you train a model from scratch on your small dataset. So that's why many people nowadays use this type of transfer learning method called fine-tuning. So all of the code is located in here. In my in our case study, we're gonna use the combination of this collab version with the code from here. The code is almost the same, but if I'm not mistaken, this was the earliest example of training, and in a collab version it's the latest example. Some of the libraries changed, that's why in a collab version they use other methods and functions, but they are used for the same purpose, so nothing changes. Model is not changing in here, so just some codes were changing. So let's begin our training process. Everything I just copy pasted from this tutorial to my notebook, and I just changed some parts because some of the functions in here were deprecated, so I just had to modify them. Then what else? So after training part, you have to test it somehow, and test will look like that, kind of on a successful training. So so let's begin. To begin, we have to run our Jupyter notebook. So there are two ways: either you run it on your local Jupyter notebook, or you run it on a Google Colab like suggested here. I'm having my Jupyter notebook in a Docker. And I have to enter this Docker file, Docker container. And I have to run it. Let's show. Yeah, I already run this. You can copy it, or you can show the process number that you used before. So it will run your Jupyter notebook. I'm using the port 9292, and because I'm running it in a Docker, I have to make it a low root so that root user can run the Jupyter notebook. In simple case, root user is not allowed to run the Jupyter notebook. So it's running in this location. Let's just open our web browser, go to the location, and you can see my training codes folder in here. So this is my already created file called segmentation test. Yeah, from this website, from the website that I have showed you previously, you have to download the file called penfield.pet.zip from this location, downloading and extracting the zip file. It's a link to the dataset. I've already downloaded it to this location. Yeah, this location, I extracted it in here, so we have this kind of folder. So let me describe the structure of the folder. There we have 3 folders, subfolders in our dataset. Then 2 files, readme and added objects list, txt files. So readme, as you may understand, like in a GitHub, it's used for explaining what is this folder for, the structure of the folder, the content of the folder, and in this case, like, it's describing the data set. So then added object list is describing what kind of objects are in the dataset. If I'm not mistaken, this is the list of the objects that were added lately to the existing dataset, because there are only like 40 or 50 images. They are the images that were written 60 images, 67. I suppose they are the images that were written lately after creating the initial dataset. Then we have here 3 folders. First folder is PNG images. It's the original image that is gonna be used for training. Then we have the second folder. It's the mask for each image. I don't know if you can see this. There are the people masks that were drawn on the previous pictures from this folder. Then on the third folder you can get the annotations of image size, like database type, and etc, etc. So the bounding box for object 1 its location, bounding box for object 2 and its location, and the description of where the mask for this image located. For example, for object 2, the mask is located in this mask PNG file, and for object 1 the mask is also located in here. The algorithm will find the mask by using the bounding box information. So we have 3 files for training. In our case, it's PNG images, pedestrian masks, and annotations, including the information about bounding box and masks locations. So as we described in a previous lecture, the mask is some kind of a pixel-wise description of an object, like pixel-wise area of the object. For example, if it's a person, all of the area where the person is located is masked using the pixels and using its pixels, and if it's another object, then also every part of the object will be described using the pixels. So if you want to do the segmentation, you need these kind of 3 folders: images folder, masks folder, and description annotation showing the bounding box information and masks information. So our segmentation code is already running. Let's just reload it. So let's clear the output and begin from scratch. It should take some time. Okay. Okay, I think I've So basically we will need touch, PyTouch, touch vision, NumPy, and PIL packages. All of the other codes, utility codes, can be downloaded from the Colab version. Then let's begin. To run, we just press the Shift Enter, and while loading it will show you the asterisk like in this example. The first code, the first cell is running the code to load the libraries, needed libraries and packages, code packages. Yeah, in Python it's called package. So the second cell is running the class function or a class implementation. Class implementation. So the class is called benefit and dataset. It's dedicated to read and use the benefit and dataset that we downloaded earlier. So it's using the touch utils and other functionality. I'm not going to describe what exactly does this class. The main functionality of this class is to load and to be able to load, to feed the benefit and dataset to our model training functionality. So the third cell is used to load the model. The pre-trained model. As you can see, it's like loading faster CNN Resident 50 model. There are a number of classes, two. The first class is the person, and the second class is the background. Like in our masks, there is a black background and some kind of a gray mask. Then let's run the fourth cell. The fourth cell is like assigning the backbone. The backbone will be MobileNet v2, and the output channels will be 1280. Then another functionalities like engine generator, ROI, and etc. All of them were taken from the Touch Vision library. They are default like parameters for them for this type of task. So it's loaded only. Then I have to say that MaskQ CNN is based on the faster CNN, the previous version of the algorithm. After training and testing this code, I'm gonna explain everything to you about MaskQ CNN, faster CNN, and other things. So in here we're defining our model that is going to be trained. Then in here useful functionality to convert the image to tensor to fit it to the model. So it's some UDO's functionality also. In here we are testing that the base model is working well with our Penfield and pedestrian dataset, and we are also loading the data. We are defining the dataset in here, Penfield and ped, and using the data loader functionality of the PyTorch, we are loading the dataset. Then in here we are defining our dataset. Then we are assigning some kind of transformations from image to tensor transformations to it. Then we are creating seeds to train and to split the dataset into train and test sets, and we are also defining the training and validation data orders. So let's just test our that our original model is working well. You can test it just by running the predictions, and if it shows you that kind of information about the boxes and other scrolls and labels, then you can see that it's working well. If it's not working well, it will show you some kind of an error. So that's the main part where we begin the training. We are training on a CUDA device, on a graphical processing unit, GPU. If you do not have the GPU, it will train on the CPU. Then this main code is responsible for getting the model instance, assigning classes to it, and porting the model to GPU, and in this place start training assigning some parameters of the model, assigning epochs, how many epochs you have to train. In our case we are training for 10 epochs, and training using the above information. Then so before we begin with this code, before we begin with running the main, let's check the memory of our device. So let me just pause the recording for 5 seconds, because usually after I'm running the training code, it will sometimes my computer will halt because I do not have my GPU card did not have enough memory. Because the training process, you can see here that my GPU card has 3000 megabytes or 3 gigabytes of memory, and the training process will take 2.8, 2.9 gigabytes of memory. So sometimes the memory is not enough, and that's why the process sometimes holds my computer. That's why let me pause the video in here, and we'll continue it again before I'll press the train button. And before before I run the training cell.